Bismillahirrahmanirrahim. We'll continue. We did this one. We'll find the radius of convergence and the interval of convergence. Okay. For what values of x do the following power series converge? The same idea. This is, we'll say L will be limit n goes to infinity. An plus 1 or an. That will be limit n goes to infinity. X to the power n plus 1 over n plus 1 times, times the reciprocal of this, which is n over x to the power n. That can be limit as n goes to infinity. Sorry, as n goes to infinity, absolute value of x, and this is n over n plus 1. What is the limit of this? Very clear, it's 1. So the answer is absolute value of x. I want this less than 1 for convergence. So I need x to be minus 1 and 1. And what is r? R will be 1. This is the radius of convergence. Yeah, since I have x minus 0. Okay. So now check endpoints. Check endpoints. X equal 1. You have what? You have summation n equal 1 to infinity. Minus 1 was n minus 1. 1 over n, which is n. 1 to the power n, which is 1 over n. That's 1 over n, which is 1 over n. That will alternating with known alternating harmonic series, which is converges. Now x equal minus 1, what you will get summation n equal 1 to infinity, minus 1 to the power n minus 1, minus 1 to the power n over n. And that, you need to be careful. It will be minus 1 to the power n, minus 1 to the power minus 1, minus 1 to the power n over n. This is minus 1 to the power n times minus 1 to the power n is minus 1 to the power 2n, which is 1. Let me write it in details. Minus 1 to the power 2n. This is exactly 1, because 4 is even. So I'm getting what the series minus 1 over n, which is very instant. Very clear diverges, harmonic series. Or diverge. So my interval convergence is what? 1 included, minus 1 not included. So open from minus 1 and close from 1. So when x is what? Greater than minus 1, less than or equal to 1. And diverges everywhere. Converges for this and diverges elsewhere. Okay. This one, let me check. Same thing. I have the limit. It goes to infinity. For this, an plus 1, a over an. That will give me what? Limit n goes to infinity, minus 1, n plus 1, that's minus 1 to the power n, x to the power, be careful here. And instead of n, I'll write to n plus 1 times the reciprocal of that. Okay, let me do it in details. Limit this with this, give me minus 1 with the absolute value. Done. So I have x to the power 2n plus 2 minus 1, that 2n plus 1 over 2n plus 1 times 2n minus 1 over x to the power 2n minus 1. That give me limit. That will be 2n plus 1 minus 2n plus 1. That will be x squared And then I have 2n minus 1 over 2n plus 1. So I need, that will give me x squared. Less than 1. So I have x squared less than 1. That implies x is between minus 1, sorry, minus 1 and 1. Between minus 1 and 1. Okay. Yeah. Now, let me check endpoints. Check endpoints. What I have. If x equal 1, that will be summation n equal 1 to infinity. Sorry. Summation n equal 1 to infinity. Minus 1 to the power n minus 1. Okay. Minus 1 to the power 2n minus 1 over 2n minus 1. Okay. This series will be what? Summation. Be careful now. Yeah. This powers, I'm taking x equal minus 1, sorry. I'm taking x equal minus 1. Yeah. I put instead of x minus 1. Okay. Now this power is what? Minus 1 n minus 1 plus 2n minus 2. Okay. Over 2n minus 1. Am I right? Yeah. That would be what? Summation n equal 1 to infinity minus 1 is n minus 1, sorry, to n minus 1. It's minus 1 to the power 3n minus 1 to the power minus 2. Or let me do it this way. Yeah, let me do it in steps. Over 2n minus 1. This is 1 with an even power, okay? Summation n equal 1 to infinity. Can write this as minus 1 to the power 2n minus 1 to the power n over 2n minus 1. This is 1. So it is this one, which is converge. Alternating harmonic series. Okay. Now, I take the other case, x equal 1. Yeah, this is easy. What I will have, summation n equal 1 to infinity. Oops. Summation n equal 1 to infinity of what? Yeah, instead of, this is a half minus 1 to the power n minus 1. 1 to the power 2n minus 1 over 2n minus 1. Yeah, this is 1. 1 to the power, this is 1. So it's summation, which is still alternating, not harmonic, alternating, yeah, alternating series. No, the say harmonic. Yeah, it's not far from the harmonic, but it's a alternating series. But this, the limit goes to 0 and it's decreasing. And the same thing here, alternating series. Very clear to check. Alternating series. So it will converge. So it's the interval will be all of them close, or I say x is this than greater than or equal minus 1, this than or equal to 1. And diverge converges for this interval, diverges elsewhere. This to check the limit as n goes to infinity, an plus 1 over an. I think now it's very clear what are we doing. Huh? Just we need to do calculation. Xn plus 1 over n plus 1 factorial times reciprocal of that n factorial x to the power n. That will be, don't forget the limit, Yeah, be careful. This is n plus 1 times n factorial, where this cancelled with this. So I have x over n plus 1. So as n goes to infinity, this will be 0, which is less than 1 for any x. So it converges for all x. Converges absolutely. Not only converges absolutely for all x. So it is r. R will be infinity, and the interval minus infinity to infinity. Okay. Find the rate of convergence of this two and the interval convergence. Same thing. We'll find the limit as n goes to infinity over there of what is that? N plus 1 factorial x to the power n plus 1 over 1, 3, 5 to n minus 1. I need the next term to n plus 1 times the reciprocal of this. Okay, that will be limit n goes to infinity. Yeah, be careful. This with this, give me n plus 1. Okay. This with this, give me x. And this cancelled with this over to n plus 1. And that I can rewrite it. I can take absolute value of x outside, and this is n plus 1 over 2n plus 1, which is half. So I have absolute value of x over 2. Than 1. So I have absolute value of x less than 2. So my r is 2. And this implies x between -2 and 2. Okay. Now what I will do, I'll check the endpoints. Check end points. Okay. X equal to, let me start with x equal to. So you have, what is the summation? Summation n equal 1 to infinity n factorial 2 to the power n over 1, 3, 5 times 2n minus 1. How to check this series? Yeah, you need to notice one thing. This series, if you think about it, it's 1, 2 to n. This is the n factorial, and this is 2 to n time over 1, 3, 5 to n minus 1, which is, if you look at the series, it will be what? 1 times 2, we do it 1 by 1. 1 times 2, this is 2. 2 times 2, 4. 3 times 2, 6, 8, until you reach to n over this. Will that help? Yes. Because now if you look at this, it will be what? 2, 4, 6. Greater than 1. Yeah, 2 is greater than 1, 4 is greater than 3, 6 is greater than 5, and so on. So this expression is greater than 1. So the limit, this impossible to be 0, not equal to 0. So this series will do what? Diverges by n-term test for divergence. Yeah, I'll take more space just to see the other side, which is the same idea exactly. Yeah, but just for completeness, let me do the other side. which is what? What is the series? Series x equal -2, and my series is n equal 1 to infinity, n factorial -2 to the power n over what? 135 times 2n minus 1. Using the same trick, or we can write it as what? -1 to the power n factorial 2 to the power n over this. How they said, these things is greater than 1. So this, the limit as n goes to infinity of these things, it's impossible to be 0. Actually, it will be doesn't exist. Yeah, impossible to be 0. So the series diverges by n-term test for divergence. Now we have this idea, this simple idea about how to differentiate and integrate power series. So if you have this power series, you have a function which should be written as this way, where you have this radius of convergence and this R radius of convergence and this the interval of convergence. Assume if it's differentiable and therefore continuous. What will happen if I want to find f prime? I will do it term by term. I'll do this, the derivative of this. Notice f of x. Yeah, but you need to be careful. An x minus c to the power n. What is f prime? N equal, I will leave it. This is n x minus c to the power n minus 1. Yeah. I can make this 0. It's correct. However, if you notice, at 0, this will be 0. So this will be equal, n equal 1 to infinity. Why? Because at n, it will be 0. So I can start the series from 1. And the same thing, if we think about f double prime. F double prime will be what? Summation. Now it will be an n minus 1, x minus c to the power n minus 2. Now n is starting from where? N will start from if I put 0, then that will not make, yeah, that will, it will be the same. If I put 1, this will be 0. So everything will be 0. So I can make it starting from 2. And this is what they did. Yeah, for the f prime. For the integral, we do the integration of f of x. Okay. This is just to find the first derivative, second derivative. That will make it. You need to be careful about the starting point. Now, when it comes to the integration, if I have this, what will happen to the integral? Let me do it here. Let me try to squeeze it here. Integral f of x dx. So I need to find the integral of this series, summation. Which is just a polynomial. That will be what? Summation n equals 0 to infinity. Okay. I have what? An. This one is something to the power n. Something linear, coefficient of x is 1. So I can do the integral easily. that will be x minus c to the power n plus 1 over n plus 1. Don't forget the constant of integration, plus c. This is what we get. Now, the radius of convergence, if we do the derivative or integrating, will be the same. R will not be changed. We have no changes in R. The problem just with the interval of convergence. And only in the endpoints. Maybe the endpoints only differ. You need to check the endpoints. Other than that, it will be the same. So just when I do integration or differentiation, the only concern is about the interval of convergence and only at the endpoints. Okay, let us see examples and then we understand it. Okay. If you have this power series, has the radius of convergence R. Okay. Differential. So what will be? Actually, we did this. Yeah. So it will be f prime. Yeah. I have f of x. Let me do it here. F of x, because I'm doing it here and I think 0. Then just to tell you what's going on. Actually, we did it before. What will be f prime? It will be summation n equal n say n x minus a to the power n minus 1, starting from 1. The prime will be, this is starting from 1. Okay. Term by term differentiation. When it comes to the integration, I need to do only also the same thing, term by term differentiation. Now, now we can see it. Now this is f, this will be f prime, which is the same as this. No need to be bothered with this, just you do it to the series right away. The radius of convergence as z should be the same. So it's similar like to this. D of x of this, I can take the derivative inside the summation. Integral of the summation, I can take the integral inside the summation. Yeah. The radius of convergence remain the same, as I said, only the interval of convergence does not mean the interval of convergence will remain the same. It will the original series converge at each endpoint. Just I need to be careful with the endpoint. Okay. Now, this is defined for all x, so it will be j prime at x. It will be the derivative of this. All of this is a number. Yeah. All of this is just a number. So it will be the derivative. It will be the summation n equals 0 to infinity. This is just a number. I will leave it as a number. Then find the derivative of this. What's the derivative of this? 2n x to the power 2n minus 1. Now rewrite it. So I can rewrite it. Yeah. Oops. I can rewrite it as summation n equals 0 to infinity minus 1 to the power n. N x to the power 2n minus 1 over this 2. I can deal with this 2 to the power 2n minus 1 n factorial square. Yeah. As I said, for f prime, if you have this series, so f of x, which is 1 over 1 minus that's what we will do in section 9.9. That will be summation x to the power n, where n equals 0 to infinity, and x between minus 1 and 1, because we'll do it as a ratio, as a geometric series. So the interval convergence will not be changed. So it will be f prime, just the derivative of that, n x to the power n minus 1. Don't forget, starting from 1, starting from 1. This is the first derivative, and this is the second derivative, which is summation n minus 1 x to the power n minus. Actually, we need that in math 208 later. Okay. Now let me take this series, find the integral convergence for each of the following. The integral, the function, the derivative. Okay. So this is my function. My function is summation equal 1 to infinity x to the power n over n. My function. First, I need to find the integral, then I'll find its integral f of x dx. That will be what? C plus integral of this, which is summation in equal 1 to infinity. I have what? 1 over n times x to the power n plus 1 over n plus 1. The integral of this, which is C plus summation in equal 1 to infinity x to the power n plus 1 over n plus 1. Okay. Yeah. Okay. Now, I need to check the interval of convergence for this series. Yeah, for sure, for this series, I'll check the interval of convergence. Okay. So what I will do, the ratio test. The ratio test, we have limit and goes to infinity, x to the power n plus 2 over n plus 1, n plus 2, reciprocal of that xn plus 1, that give me what? Limit and goes to infinity. I have x, yeah, let me write absolute value of x, then absolute value n minus 1 over n plus 1, n plus 2, same degree. So this is 1, absolute value of x, less than 1. So r equal 1. And the interval, x between minus 1 and 1. Now check endpoints. Check endpoints. At x equal 1, that will be summation n equal 1 to infinity, 1 over n times n plus 1. Yeah, this I can show you it's converging, not diverging. It converges by limit comparison test with this series, 1 over n squared. Very easy to see. Yeah, so it's converge. Now for x equal minus 1, what will happen? It will be what? It will be the series minus 1 to the power n plus 1 over n plus 1. Very clear alternating series converges. So the interval for integral of f of x dx is minus 1 to 1. The closed interval. So this is for the integral. Okay. Now we'll go to f. F of x summation x to the power n over n factorial. Over n, is it? Over n, not n factorial. Yeah. I can assure you it will be this. So the main interval should be the same. Just you need to be careful about the endpoints. This is what I want to show you in this example. So now do the limit n goes to infinity, x to the power n plus 1 over n plus 1, n over x to the power n. Very clear, this absolute value of x. Yeah, the limit of this is 1. Huh? Yeah, less than 1. So x between -1 and 1. Now check endpoints. Check endpoints. Actually, we did it before. X equal -1. I have this series. Alternating harmonic converges. X equal 1. I have this series, which is very clear diverges harmonic series. So the interval will be what? -1 closed. This is open. Now we'll go to the third one. F prime of x. What is f prime of x? Just find the derivative of this. That will be summation n equal 0 to infinity. What's the derivative of this? N x to the power n minus 1 over n. And that will be summation n equal 0 to infinity x to the power n minus 1. Okay, that will be f prime into the power. Yeah. It will be x to the power n will be n x to the power n minus 1. Yeah, actually starting from 1, sorry. Yeah, this is actually starting from 1. So all series are starting from 1. Yeah. So this is 1. As in the original series. Okay. Okay. So now check the limit as n goes to infinity. An plus 1 or an limit of what? X to the power n plus 1 minus 1. That will be x to the power n over x to the power n minus 1. Also the value of x less than 1. So x between -1 and 1. Now check endpoints. This is for f. Check endpoints. At x equal 1, I have this series. 1 to the power n minus 1, which is 1, which I know it's diverges. By n term, x equal -1, worse than that, -1 to the power n, which is for sure diverges. The limit will not go to 0. Actually, the limit does not exist. And the limit here is 1. So for the same reason, they are diverging. So the interval will be what? -1 to 1. As you notice, the interval is the same, -1 to 1. The only changes are what? At the endpoints. And the integral may add the endpoints for the function. And the derivative, you may lose the endpoints for the function. Yeah, should I keep more space? No need for it. Okay. Finding interval convergence for another function. I want to do f prime, f double prime, and the integral. Yeah. Okay. So I will do f. What will be the limit? As n goes to infinity of -1 to the power n plus 2. Yeah, that will not make a problem. X minus 5 to the power n plus 1 over n plus 1, 5 to the power n plus 1. Sorry. Times the reciprocal of that, n5 to the power n over -1 to the power n plus 1, x minus 5 to the power n. Okay, that will be limit n goes to infinity of what? This is minus, this is gone. That will be x minus 5 to the power 1. Here I have what? Over 5. Yeah, over 5. N over n plus 1. This limit is 1. So I have x minus 5 over 5 less than 1. So I have this less than 5. So I have x minus 5 between minus 5 and 5. So x between 0 and 10. Then 0 and 10. This is for f of x. So check endpoints. Check endpoints. Okay. X equals 0. What will happen? We'll have summation n equal 1 to infinity minus 1 to the power n plus 1 minus 5 to the power n over n 5 to the power n. This will be minus 1 to the power n plus 1 minus 1 to the power n 5 to the power n over n 5 to the power n. This is cancelled. This will be what? Minus 1 to the power 2n plus 1. 2n will be gone. So I have, because minus 1 to the power 2n is 1, huh? Yeah, let me do it here. That will be minus 1 to n plus 1, which is minus 1 to n, minus 1 was 1. This will be 1. So the answer is minus 1. So I have minus 1 over n diverges. Okay, now x equal 10. What will happen at x equal 10? Yeah. I have the series n equal 1 to infinity minus 1 to the power n plus 1. 10 minus 5, which is 5 to the power n over n 5 to the power n. This is cancelled. So you have alternating. So this is converged. So what is the interval? Open 0, close 10. Okay. Now when it comes to f prime. Yeah, by the way, what is r here? R equals 5. Yeah. Now when it comes to f prime, let me remember f. F of x equal what? What is it? Summation. Oops. Oops. What is it? X. I think this is n plus 1. Yeah. Okay. What will be f prime now? F prime will be summation n equal, make it 1. See what will happen. Minus 1, n plus 1. I have here n x minus 5 to the power n minus 1 over n over n 5 to the power n. Okay. Which is n goes with n, huh? So I have summation n equal 1 to infinity minus 1 to the power n plus 1 x minus 5 to the power n minus 1 over 5 to the power n. Okay, that will be f prime. Now be careful about the interval. Look, for sure without checking, r will be equal to 5. Same r, same radius. No need to check. You check it only for one of them, either f prime, f prime, or the integral. Okay, that will be 5. Clear. Now we'll check the interval. The interval, yeah, I need to check only the endpoints. And by the way, yeah, the derivative will take a point, will not add a point. But let me check both. So for sure, 0, it will not be included because it was not included in f. F prime will make it less or the same. The integral will make it more or the same. Only the endpoints. So let me check endpoints. So check endpoints only. Okay. Check x equals 0, which I know it will not. but let me just for completeness, then just to show it to you, that will be what? Minus 1 to the power n plus 1. I have minus 5 to the power n minus 1 over 5 to the power n. That gives me minus 1 to the power n plus 1 minus 1 to the power n minus 1, 5 to the power n over 5 to the power n. Yeah? Yes. So this is cancelled. So I have what? Minus 1 to the power 2n, which is 1. So I have summation of 1, which is divergence. I know it's diverge. Now x equal 10. I have this n equal 1 to infinity. Minus 1 to the power n plus 1. 10 minus 5, which is 5 to the power n minus 1 over 5 to the power n. That give me what? Sorry. Sorry. This is... it will diverge, but it is minus 1 to the power 5 to the power n minus 1, which is 5 to the power n, 5 to the power minus 1. Okay, so this is cancelled. This is 1. So I have summation of 1 over 5, which is still diverges. Okay, the limit will not equal to 0. The same thing here. I have summation n equal 1 to infinity minus 1 to the power n plus 1, 5 to the power n times 5 to the power minus 1 over 5 to the power n. This is cancelled. So for sure, the limit does not equal to 0, which is this one. Summation n equal 1 to infinity. For sure, the limit of this will be either 1 over 5 or minus 1. So the limit does not exist, so it will diverge. So the interval for f prime, it's 0 and 10. Okay. Now let us go to f double prime. Where is f prime? This is f prime. This is go to f double prime. F double prime of x. That will be what? We'll do the derivative now. That will be summation n equal 1 to infinity minus 1 to the power n plus 1 n minus 1 x minus 5 to the power n minus 2 over 5 to the power n. Yeah, any cancellation? No. Look, this one r equal 5 and the interval will be 0 to 10 without check anything. Why? Because as I said, the derivative would make the function before, the interval will make it less, will not make it more. I'm talking about only about the endpoints. So either they will take endpoints or it will be the same. Since I don't have endpoint for f prime, for sure for f double prime, I will not have endpoints. Yes. Now let me take the integral. Yeah, I need more space, I think. Yeah, by the way, there was a page here. I can put it here. Yeah, that will make it okay. So what is the series? What is f of x? Is this one? So I have f of x summation minus 1 to the power n plus 1. Yeah. Yes. What is this one? Okay. So I need to find the integral now. Okay. The integral will be what? Will be the integral of this, which will be summation, starting from 1, yes. N equal 1 to infinity, integration of this, minus 1 to the power n plus 1. This is just a number. This one, I add the power and I divide by it. what will be R? R will be 5. R will be the same. R will not change. Either you take integration or integral. But what may change? The interval. Okay. So now I'll check, but the interval, the integration will make the same interval, or may they add endpoints? So I'll check both of them. So I will check endpoints. So my intervals, either it will be 0, 10, or 0, 10, or 0, 10 close, or both close. By the way, don't forget F is what? What's the interval for F? Yeah, just interval for F. Interval for F, remember, it was 0, 10 close. So this one cannot be this, for sure. It should include the 10. This cannot be this. So either this or this. Either I will add the 0 or I will keep it as is. This is what will happen. And by the way, I will add the 0. But for sure, the 10 will be there. So just the integration either will keep the same interval of convergence, or they may add the checkpoint, the endpoints. Okay, so let me check the endpoints. Now for x equals 0. Let me see what will happen. I have the series n equal 1 to infinity minus 1 to the power n plus 1 minus 5 to the power n plus 1 over n 5 to the power n times n plus 1. And that will be summation n equal 1 to infinity. Have the same power, that make it easier. 5 to the power n, which is 5 to the power n. 5 to the power n times 5 over n 5 to the power n plus 1. So this is cancelled. So I have summation n equal 1 to infinity 5 over n plus 1. This is converged. Why? By limit comparison test with this series. Yeah, very clear. Okay. Now check the other one. So 0 will be included. 10 for sure it will be included. Yeah. So summation n equal 1 to infinity minus 1 to the power n plus 1. This is 5 to the power n plus 1 over n 5 to the power n. And that will be, yeah, don't forget I have n plus 1 here. That will be summation n equal 1 to infinity minus 1 to the power n plus 1. This is 5. 5 to the power n will be gone. N plus 1. This is converges by the alternating series. Right. AST, alternating series test. Goes to 0, decreases. Very clear if we take this. Yeah. Okay. So what will be the interval for the integral f of x dx? Is what? All of them is closed. Yeah, don't forget there is plus c. Who cares? Yeah, there is plus c. Okay. So that's what I will stop here. Then I will do some of the old exams questions. Not that much, but some of it. Okay. So this question I think is a good one, where I have the function, I have the integral, I have f prime. Also this one, have the function f prime, f double prime, and the integral. As I said, for the derivative, the interval, I mean, no, r will be the same. Differentiate, integrate, r, the radius will not be changed. This is the rule. The radius will not be changed if we do integration or differentiation. What will happen? The endpoints maybe. And the derivative will take, maybe it will take away some endpoints. And the integral it may add endpoints. That's mainly the thing, and you can see it easily here. This is the function. The derivative took this endpoint. The integral add this endpoint. It may add, it may not. It depends on the problem. Okay, so let me stop this video, and then I will continue in the next video. Yeah. Thank you.